Good evening everyone. Welcome to the third video on the video series of the IB to IIT Transition preparations. Okay, so for the past two videos, we have been looking at how to solve problems, and the first video was about something related to the orbital velocity and the time period. And we looked at, like, for example, you have an Earth and you have a planet, sorry, you have a satellite, and this satellite now tries to move around, and suddenly, all of a sudden, the central force or the force in the planet increases to one more term. Then what can happen to the time period of the satellite? And that's how we related. And towards it, one extra concept that we had to learn, or maybe you had already learned so far in your HL, if you're a HL student, is that how to relate a potential energy to force. And then you already been learning something about the potential energy is always seen to be negative in case of the Earth. But there we learned something about the potential energy is seen to be positive. And if that is the case, what happens to the net force? Net force will not be directed downward, it will be directed outward also. Net force will not be directed totally outward, but part of it will be there. So net force you calculate as Fc minus Fg, right? That's what we have learned. The second problem recently we had learned about, you have a coil of wire, and you have a coil of wire, a circular turn of wire, which has been suspended with the help of a string. And when a current is made to pass through it, then what can happen is, let me assume this is your coil of wire. When current is made to pass through this one here, and this is being tied over here, so this starts moving upward like this, right? Now the question was about how do you relate the angle made by this bangle, or maybe the circular coil, with respect to the vertical, and in terms of something related to the mass of the coil and the magnetic field applied, the radius of the coil, and so on. Okay, so that was also an interesting thing to work with. So I just showed you about how to solve such kinds of problems. The extra thing that you learned there is about how do you calculate the torque due to a magnetic field, which in IB syllabus we don't have it, but maybe in CBSE we do have it. Okay, now let us move on to the next part. The next part is today's problem. Now let me share my screen so you can look into it, and let me know in the comment section, how did you go through it? Did you understand this? Did you face any problems in this? Do you want my pace to be much more slower? You want me to introduce the concepts first? Whatever it is, let me know so that I can fine tune my way of teaching. It's also helpful for both of us. Okay, now let me just share my screen. Now let us start with this. So the question reads something like this. It tells you a tennis ball with radius r equal to 1.5 centimeter floats in water. Okay, this is floating in water. The density of water is 1000 kg per meter cube. Water's density is given, and the ball has a mass of 3 grams. Calculate the buoyant force acting on the ball. So very simple question when it is completely submerged. So what is your answer? We know that buoyant force is given by density of the liquid multiplied by the volume of the ball multiplied by gravity will give you the buoyancy force. Okay, if it floats, what fraction of the ball will be submerged? So this has been asked. Okay, so it is just floating. So we do not know what has been inside, what has been outside, how much volume is outside. It's what we need to do. Let me solve this first, and then we will proceed for the next one. Okay, a table tennis ball with radius is given. Let me just go back. Yes. So therefore, this is the container. I'll take a different color pen to make it more clear. Right. This is a container. The water is being filled until here. Now this is how the ball is floating here. Okay, so what we need to do, if it is floating, then what is that we have? We have density of the ball. So what is being asked? So calculate the buoyancy force acting on the ball. First question. So FB will now be equal to density of the liquid, volume of the ball multiplied by G, right? So what is density of the liquid? 10 power minus 10 power plus 3. And what is the volume of the ball, which should now be equal to 4 by 3 pi r cube. Volume of the ball is how much? Multiplied by G, multiplied by 10. If you do all these calculations, you will get the value. I'm not doing the calculation, I'm just showing you the method. Okay, and then next is, because r is already known to you, you can substitute, you can get the answer. calculate the buoyant force acting on the ball when it is completely submerged. This is done. Determine whether the ball will float or sink. So how do I know this? So what we need to do is, see, the mass of the ball. What's the mass of the ball? Mass of the ball is 3 grams. Mass of the ball is 3 grams. What's the volume of the ball? This is already given to you. Radius is given. Volume should be equal to 4 by 3 pi into 1.5 into 10 to the power of minus 2 whole cube. Okay. If I calculate this value, let me just calculate this value to find out whether it floats or not. It's here. Okay. So this should be 3 multiplied by 10. First, let me calculate the denominator so that I can easily do this one, right? We cancel this. This is nothing but 4 by 3 pi into 1.5 whole cube. What is 1.5 whole cube? 1.5 multiplied by, or maybe x to the power of 3 is equal to 3.375, right? We're doing it correctly. Multiplied by 4 multiplied by 3.14 divided by 3. When I do this, I get 14.13 into 10 power minus 6. And if I take the reciprocal of this, multiplied by 3 multiplied by 10, this is 3 grams, right? Okay, I am sorry, this is not 10. This is what we make a mistake over here. This 10 power minus 3 over here, right? So therefore, I get the answer 0.21. So this would be 0.21. And here you have 10 power minus 3. And here you have 10 power minus 6. So this totally comes out to be 0.21 into 10 to the power of plus 3, which should now be equal to 210 kg per meter cube, right? What is the density of water? Density of water is 1000. Okay. So therefore, do you think it will float or sink? This will definitely float. Why does it float? Because if the density of the object is less than the density of the fluid, then definitely it will float. Okay. Very simple thing, 9th standard syllabus. So this is also okay. If it floats, what fraction of the ball will be submerged? Next question. So how do you find? So what you do is, let me assume the volume inside this is equal to some, inside this is V1 and this is V2. Okay. So therefore, now what do? We can say the total amount of mass of fluid, the volume of fluid which has been displaced over here should now be equal to density of the liquid multiplied by V1. Multiplied by V1 is nothing but the volume of fluid which has been displaced. Okay, and then this should now multiplied by G will give you the buoyancy force. So buoyancy force has been acting like this. Let me write this as FB. And why, if it is acting like this, then it should be thrown out, right? Why is it not going upwards? Because the mg is acting downwards. Mg is acting like downwards. So what is the value of mg? Mg is already known to you, which is 3 times 10 power minus 3 multiplied by g. This g and g will go away. So I can find out the value of V1 here. V1 can be written as 3 into 10 power minus 3 divided by V1. What's the value of rho L? 10 cube. 10 cube. So which should now be equal to 3 into 10 power minus 6. 3 into 10 power minus 6 is nothing but the volume of the ball which is inside. Now what is the total volume of the ball? Somewhere we found out, no? We found out what is this now? We did not find. We found out only this value over here. Okay, what is the fraction? I'm not calculating, I'm just showing you this. So fraction is nothing but, so we'll take this V1 divided this by the total volume. So this will be 3 into 10 power minus 6 divided by 4 by 3 pi, and what's the value of R? 1.5 centimeter. 1.5 into 10 power minus 2, the whole cube. Okay, do this fraction, you will get some value. That is the answer. Okay, I'm not going to do this one here. I'm just showing you the method as how to calculate this. Okay, so all these three are very simple things which you have already done. So we need not redo it once again. Let me move on to the next one. Level 1 problem is quite easier. You could have done it easier. Level 2, a table tennis ball. I need to change my pen color because it's already in white. So I'll make this as a black one. Right. A table tennis ball is pushed into the water and held at a depth of 50 centimeter. Now the question is a slightly different one. So you have a tank, you have water here. Now you're not making this one to float, okay, because it's already floating is done. Now I apply my hand, and what I do is I make this ball to go inside, and I hold my hand here so that the ball doesn't come out. That's what it says. Tennis ball is pushed inside the water and held at the depth of 50 centimeter. So this depth is given to you as 50 centimeter. Okay. Below the surface, then release from rest. The moment you go from here, then after some time, you remove your hand. The moment you remove your hand, what will happen? The ball will immediately rush to the surface. Do you think it will stop here? Sometimes, okay, if the depth is much larger, it will come faster, it will jump here. It will go like this, and again gravity is pulling, so it goes like this, and once again jumps over here, and it keeps on bouncing like this over here. And finally, it comes to an equilibrium. Okay. Now, and has the same properties as level 1. Okay, what are the properties? We got the value of R, which was equal to 1.5 centimeter radius. Mass of the object was seen to be 3 grams. G is same 9.8 or 10. Everything is same. Okay, and this is water, and it also says the density of the liquid is equal to 10 cube. No issue. Then, what forces act on the ball when it is submerged and moving upwards? What are the forces that acts on the ball? The moment it is moving upwards. So what's happening over here? Well, let me say if I consider at this position. So what are the forces acting here? At this position, mg definitely is acting. Wherever you consider mg is acting. And what is the force acting here? The water molecules don't like this tennis ball, so it is now trying to push it upwards, right? So Fb is acting upwards over here. So therefore, the forces that are acting is, you can say Fb acting upwards, Fg acting downwards. Okay, don't write by 2 arrows, I'll write by downwards over here. Okay, then using energy conservation, calculate the speed at which the ball would emerge from the water surface. Ignore air resistance and viscous force. What is a viscous force? Okay, suddenly there's something given over here. What is a viscous force? Viscous force is nothing but the friction offered by the water molecules to the solid surface. So how does it act? If you ask me, okay, if the ball is moving like this, it will act downward like this along the gravitational force. If the ball is moving downwards, then what will happen? Friction will act upwards. Okay, it opposes the relative motion. So instead of considering something like mu times n, which you consider in solid surfaces, here we don't consider that. We consider this Stokes formula, which is 6 pi eta Rv. But anyway, you should be happy in this level 2 that he has not considered the viscous force and he is only considering this part. Okay, now what is he asking? Using energy conservation. Nobody will give you this one. Okay, I have just put it across because if I just ask you to find out what is calculated speed, you will not be able to do it. You will be thinking whether you should use V equal to U plus AT or should I use something else and so on. So as a result of it, I have just put like this over here. Okay, now calculate the speed at which the ball would emerge. Now you need to find out, okay, the moment it is being pushing like this over here, when it comes to the surface, it doesn't say, "Arey, I have reached the surface, I'm not going to jump." It says, okay, let me try with all my might and jump upwards, right? It goes upwards. And then it goes to a certain level until all its kinetic energy becomes depleted or becomes zero. And then it says, "Arey, I don't have enough energy, gravity is still pulling me, so I have to come down." It still comes down, right? Okay, so therefore you need to find out this. How do you do this is the question. So towards it, what we do, we find out something like the energy conservation. What is the energy conservation here? Energy conservation tells you at this point, the what is the energy here? The energy here, potential energy was 0. And what is the kinetic energy? Kinetic energy was also 0. Kinetic energy also, because you kept it together, right? It was not moving. Now let me assume it goes all the way along like this and it comes at this point. Okay, so what is he asking here? Calculate the speed at which the ball would emerge from the water surface, not here, from the water surface at this point, okay. When it reaches here, what is the energy it has? It has some energy. What is that energy? This is nothing but kinetic energy. And does it have a potential energy? Definitely it has some potential energy because it has gone upwards. It also has a potential energy. Now, what is energy conservation tells you? Energy conservation tells you potential energy plus kinetic energy initial should now be equal to potential energy plus kinetic energy final final, right? So that's what it is. What is the potential energy initial? 0. Kinetic energy initial? 0. 0 plus 0 is equal to potential energy final. It is not 0, it is some value. What is that value? It is nothing but, okay, it takes mgh plus kinetic energy. What is the kinetic energy here? Kinetic energy, as it keeps on going upwards, so it will have some velocity. At this point, definitely it has some velocity, right? So which is nothing but half mv square. Okay, you can use these values, and then you can find out that value. So you can write, where is it? Let me use my different color pen. So I will use half mv square plus mgh is equal to 0. Let me take the magnitude over here. So v square will be equal to 2gh, because g is negative, so as a result of it, this becomes minus over here. Okay, so this I can now say this is 2 into 10 multiplied by height. What is the height? 0.5 meters, 50 centimeters. No? So 2 into 0.5 is 1 into 10 is 10, and then v should be equal to root 10. So thus you will get this as some 3.1 or something like this meter per second. You get some value here. Okay, now so this question is also answered. Do we need IIT equality here? No. Okay, so just simple thing that you can easily answer this. Okay, so this is answered. After emerging, how high above the water surface will the ball rise? Will it really rise? Definitely, because it has some kinetic energy, right? When you have a kinetic energy, it will definitely start keep on going upwards until gravity says, hey, you cannot go upwards, you have to come downwards, right? So therefore, it definitely goes upwards. So how long will it go? Now the problem is similar to that of your free fall, or maybe a projectile motion, right? Something like you have a ball with you in hand and you throw it upwards. Okay, the moment you throw it upwards, your initial velocity was seen to be 3.1 meter per second, or maybe so much, root 10 meter per second, and then it keeps on going upwards. What happens? The velocity keeps on reducing, it goes to a certain height and says, okay, my velocity is 0, I can't go upwards, right? So which equation will you use? You again use conservation of energy, right? Or you can say at this point it was half mv square, then it went to this height, this becomes mg into h. You can ask me what happened to the potential energy here. I will assume that this point is your reference level, and that reference level I make it a 0. So a difference level of reference, right? So I can do this one. So in other words, I can equate these two, and thus I can write v square is equal to 2g capital H, right? So thus I need the value of h over here. H should be equal to v square divided by 2g. So v square, v is equal to v square equal to 10 here. So just 10 divided by 2 multiplied by 10. This goes away. So which I'll get is a half over here. So h is equal to half meter. I got this answer also. It's also done. What might be the actual speed? Why might the actual speed be less than your calculated value? Why should it be lesser? What's the reason? See, you assumed when in the container, this was the surface, this was the ball here. The moment you left your hand, do you think this was the velocity? V equal to root 10 was 3.1 meter per second was the velocity? No, it was 0 here. It was 0 here. And as the ball started moving upwards, it started gaining its velocity. And when it reached this point, its velocity was 3.1. That means what was our assumption? Our assumption was not correct, right? Our assumption said that whatever is the velocity here, the same velocity is applicable everywhere, right? So which is incorrect. The velocity at this point is 3.1. Here it could be 2.7, here 2.2, here 3.2.1, 1.8, and so on. This is one thing. And secondly, we ignored one more thing. See, we ignore air resistance and the viscous force. We ignore the viscous force also. Any particle in fluid, the water molecules, they say, okay, I am an enemy to you. You cannot be with me. I am just going to push you outwards, right? There will be a friction there. So as a result of this friction will definitely act over here. Okay, this friction we have not considered at all. If I consider this, then definitely it will not be equal to 3 meter per second. So therefore, okay, if this value is lesser, then definitely this value of h will also be lesser. So what might be the actual speed by less than the actual calculated value? So you need to mention all these reasons. You know, still this is not an IIT problem. This is just a problem wherein enough amount of critical thinking, we have put it forward and said, okay, this is the way how you need to analyze it. Take up any problem for that matter. This is the way how you need to look into it. Okay, we've done so much. Next, let me move on to the next one. Now comes the real demand. JEE advanced problem. A table tennis ball has a radius of 3 by 2 into 10 power minus 2 meters. Change your pen once again. Okay. 1.5 centimeter mass is given. It is slowly pushed down into a swimming pool to a depth of 0.7 d equal to 0.7 meters below the water surface and then released from rest. Same problem, no changes. Okay, I have taken the same problem. So this is what it is, and you put the ball over here, you release it, and it emerges from the water surface at speed v without getting wet. Why do we use this term? That means it comes out from here and it comes over here. And when I say without getting wet, which means what? Which means there is no water molecules which are clinging to it. The mass of it is not going to change. There's no viscosity, or you put across all this over here. And rises to a height of h. And rises to a height h. Rises to a height h from the surface. Then all these values are given. The work done in pushing the ball to a depth d is 0.077 joules. We studied something else over here, and here I'm getting something else over here. How do I solve this? Okay, this might be confusing. Now, let us understand this. What did we study in the previous one? IIT problems. Okay, we should be something different for you, something unique. Okay, it cannot be just saying, okay, whatever you have learned in your textbook, I will give the same thing. It's wrong, right? And only then that cream will emerge out, right? So therefore, it will be something over here. Now, let us compare this question with whatever question I had asked in the earlier one. What was the question here? What forces act on the ball when it is submerged and moving upwards? Now, the work done is pushing the ball to a depth d. Now, how do you calculate work done using the previous one? What do you do? So, what was the total force over here? The total force over here is equal to Fg difference F buoyancy, right? Fg difference F buoyancy. The reason is because Fg is nothing but you applied a force and it is inside, okay, and then there is an F buoyancy which is pushing it outwards. So you applied a larger force, so you can counteract this one. So in fact, this will be Fb minus Fg. That's why I wrote this as difference. If you have taken Fg minus Fb, you would have got a negative value. But anyway, Fb minus Fg will give a positive value. This is what you need to find. So this you know how to find. You already seen that. And this multiplied by the distance from the surface, because you started from here and you pushed it downwards, distance from the surface to here. What is this now? This Ft multiplied by distance will give you the work done. Okay, now you can try doing this one here. Now first what we do is, let me find out Fg. Fg is nothing but m into g. What is m? M value is given here. Mass is 22 by 7 into 10 power minus 3. 22 by 7, you know what is this? This is pi. So what I will do is, I'll write this as a pi into 10 multiplied by 10 power minus 3. This is 1 Newton. Then what is Fb? Fb is nothing but density of the liquid, volume of the ball multiplied by g, right? And this is nothing but density of the liquid. What is it? It's now pushed inside water. Swimming pool, density of the liquid is given 10 cube. So this is 10 cube multiplied by 4 by 3 pi r cube. What is r cube here? 1.5 into 10 power minus 2. Okay, so into 1.5 into 10 to the power of minus 2 whole cube multiplied by 10. I don't have space, I'll write it like this over here. So when I do all this, this will become 4 by 3 pi into 1.5. Let me calculate this. It's better to calculate this and get an answer. Where is it? It's here. Okay, so now I will not calculate pi here because pi is common here. So I'm not going to calculate that. I'll just use 4 divided by 3 will be 1.33. This multiplied by 1.5 cube. Multiplied by 1.5 multiplied by 2.25. The reason is 1.5 square is 2.25. So I know this, I'm just substituting it. If you have a calculator, you can directly do that. multiplied by, you have a 10 over here. I get 4.5. You have a 10 here, 10 power minus 2 whole cube here, 10 power minus 6 here, 10 power minus 6 into 10 power 4 will be 10 power minus 2. Okay, so therefore, so I get this as 4.5 pi, 4.5 pi into 10 to the power of minus 2 Newton. What is this? This is nothing but your FB, FB. And what's the value of FG? FG is nothing but 10 into 10 power minus 2, 3 is 10 power minus 2, pi into 10 power minus 2. Pi into 10 power minus 2. That's why I kept this as pi only. Okay. Now I can simplify it easily. It is FB minus FG, which should be equal to 3.5. So F net is equal to 3.5 pi into 10 to the power of minus 2. What's the next step? I need to answer this one here. So I need to multiply this by D. What is the density here? D here, depth. Depth is half meter, right? So let us look at what is the depth over here. Sorry, 0.7. There it was half meter, it was 0.7 over here. So this should be 3.5 into pi into 10 power minus 2. Do I have a next page? Yes, I do have it. Yeah. So therefore, I have F net multiplied by D, which is equal to work done, should now be equal to 3.5 multiplied by 10 power minus 2 multiplied by 0.7. When I do this, so what is that I get? Just give me a moment. Right. So this should be, cancel this. Right. 3.5 multiplied by 0.7. You get this as 2.45. And there was a pi here in this case also here, right? 2.45. Oh, let me calculate that also. Only then I'll get a correct answer, right? 2.45 multiplied by 3.14. You get 7.693. I will write 7.693 multiplied by 10 power minus 2 joules, which should now be equal to 0.0769, could be 7 over here, joules over here. What was the question? The question was to prove that the work done in pushing the ball to the depth is 0.077 joules. You got the answer correctly, right? I did not use any magic over here. Use the same logic what we have learnt and we have put it across. If you neglect the viscous force in water, then the speed is V is equal to 7 meter per second. Okay, so you need to find out the speed. So this is very similar to the problem that we had discussed earlier, which is nothing but you can say V square is equal to 2GH, right? So we are neglecting the viscous force. So this should be 2 into 10 multiplied by 0.7 meters, which should now be, let me calculate this once again. This should now be, where is it? 2 multiplied by 10 multiplied by 0.7 will be equal to 14. And if I take the square root of this 14, I get this as 3.74 meter per second. But the answer is 7 meter per second. What is that I missed? H is 0.7 meters, J is 10, and this is 2. Okay. So, now what is that we need to do here? Can we use this expression here? You cannot use this. Okay, why can't we use this? If we calculate using this, I get this answer is 3.7. But why can't we use this expression? The reason is because while we do this one, we assume that the G is constant. Is G constant? When the particle is going upwards, the value of G is never going to be a constant, right? You can use this equation only when G is constant. Hey, we are doing it on Earth itself. Why should the value of G not be a constant? Because there is an acceleration definitely. It is not a free fall. There's a viscous force also acting over there. Okay, and also there's a buoyancy force over there. Forget about viscous. There's a buoyancy force over here. So because of this buoyancy force, the value of G will not remain a constant. It is not only the gravity, there's also a buoyancy force acting. If that is the case, how do we solve this? Then what you need to do is, whenever you have these kinds of problems where equations of motion cannot be solved, then directly use work energy theorem. What does work energy theorem tell you? Work energy theorem tells you that the total work done is equal to difference in kinetic energy. See, this also follows the same rule what we use in IB. In IB, what is the nature of the structure problem? The clue for the second problem will come from the answer from the first problem. So it goes in a zigzag manner, right? The same pattern has been followed here. So you calculated something here, you are going to use that as an input over here. Okay. So therefore, I'm going to write this as 0.077 is equal to half multiplied by, what's the mass of it? 1.5. 1.5 into 10 to the power of minus 2 multiplied by v square. I do not know. I'm going to put v square like this. So v square should now be equal to 2 into 0.077 divided by, this is 1.5 into 10 to the power of minus 2. Let us calculate this value. Right. 2 multiplied by 0.077 is equal to so much divided by 1.5 is equal to so much. Multiply this by, when it goes upwards, it becomes 10 square. Multiply this by 100. I get this 10.26. Now this is v square here. See, this v square, I need to get the value of v here. Take the square root of this. I get this 3.2421. What's the answer I should get? 7 meters per second. Again and again, there's a mistake being done. Why is it so? 0.077 is equal to half into 22 by 7. Okay. Okay, so we are getting v square equal to 3.7 meter per second. But this is not the right answer. Why is it not right? Because he is asking you to find out 7 meter per second, you're getting 3.7. Then what went wrong? This is a question we need to ask. See, when you have a container filled with water, do you have the ball when it is going upwards? What are the forces acting over here? FB, okay, is acting over here. FG is acting downwards over here. So the net force will now be equal to FB minus FG. So therefore, your value of A is not going to be the same. Okay, the value of G is not equal to A is not equal to 9.8. It is something else. But what did we assume here? We assume G equal to 9.8 or 10, which is incorrect, right? So as a result of it, the equation goes wrong. You are not getting the correct answer. Now what should we do? In such cases, if the acceleration is not known to you, see, again remember, when you throw a ball upwards, value of G is 9.8. When you throw a ball downwards, value of G is 9.8. But in addition to the gravity, there is a buoyancy force also acting here. Then the acceleration will be accounted due to the buoyancy force also. It can be greater than 9.8, less than 9.8, anything can happen. So therefore, you are not supposed to use the value of G here. If you know the exact value of the acceleration here, you can use it. Okay, so therefore, you are not going to use this here. Now, what is that I'm going to use? I'm going to use the work energy theorem. Now, what is work energy theorem? It tells me work done, which is equal to 0.077 from this previous one, is equal to difference in kinetic energies. What is the difference in kinetic energy? Half into, what is the value of m? M value, this is radius here, right? What's the value of m? Value of m, where is it given? 22 by 7. 22 by 7 into 10 to the power of minus 3 multiplied by v square. I do not know the value v square. We are going to find out this value. So let us calculate this. So what do I get here? So we have, okay, let me first write down v square as a subject. We'll keep v square is equal to 0.077 multiplied by 2 ones are 2 11s are. I'll simplify this itself. 7 divided by 11 into 10 to the power of minus 3. So when I do this, let me now calculate this value. So I will get this as 0.077 multiplied by 7 divided by 11 is 0.049. 0.049 multiplied by this 10 power minus 3. When it goes, it becomes 10 power plus 3, which should now be equal to 1, 2, 3, 49. 49, or v should now be equal to root of 49, which should be equal to 7 meter per second. Wow, we have got this also. See, IIT problems, we are easily solving it, right? Okay, now let us look at the next one. B is also done. And then if we neglect the viscous force in water, then the height h is equal to 1.4 meter. If we neglect the viscous force is neglected over here, then the height h equal to 1.4. What is this height h over here? Let us look at it. Read. H is this height above the surface, right? Let me find out what is that value here. So now what is that we have got? We have got the container here. At the surface, we know this is 7 meter per second, which means I'm having a ball in my hand. Now this is my surface. I'm throwing it upwards. To what height will it go? The maximum height, right? It goes to a maximum height here. And he says, according to the problem, it is 1.5 meter. This problem is about to say which is right, which options are right, which options are incorrect. Okay. So you are now determining one by one. So 1.4 meter. Now you need to find out this. So how do you do? Simple logic. You use v square is equal to 2gh, right? So how do you think, why do you think you should use this one here? The reason is because there's no other force apart from gravitation which is acting here. So you can always use it, right? So therefore, now v square, this is 749 over here, should now be equal to 2 into 10 multiplied by h. I do not know the value of h. I'm going to calculate this. Should be equal to 49 divided by 20. So when I do this, let me take up once again my calculator. So this should be 49 divided by 20. 2.45. This goes to a height of 2.45 meter, but here it says 1.4 meter. So therefore, C is incorrect. So this is true, this is incorrect. The ratio of the magnitudes of the net force, let me take up a new slide. The ratio of the magnitudes of the net force excluding the viscous force to the maximum force is 500 by 9. Now how do you do this? This is nothing but FB minus FG was the net force acting on the ball divided by the viscous force. This is what he's been asking, and he says, okay, this should be equal to 500 by 9. We need to prove or disprove. Okay. So what is the value of FB minus FG? Did we calculate it earlier? FB minus FG. FG I got 11 pi, sorry, FG I got pi into 10 power minus 2, and FG is done. F net is 3.5 into 10 power, 3.5 pi into 10 power minus 2. Let us take that value. 3.5 pi into 10 power minus 2 divided by, what is FV? Stokes theorem. This tells you 6 pi into eta. What's the value of eta? Eta is viscosity. Viscosity is 10 power minus 3. 10 power minus 3 multiplied by radius. What is the radius here? 3 by 2 into 10 power minus 2. 3 by 2 into 10 power minus 2 multiplied by velocity. Which velocity? Terminal velocity. What is that value? We calculated this to be around 7 meter per second, right? Let me see here, 7 meter per second. Do you think this is correct? This is incorrect. Okay. The reason is because we have assumed it 7 meter per second. It may not be equal to 7 meter per second. It might be lesser initially. So for a given range only, it can be 7. But anyway, nothing is given over here. So we'll just assume like this over here. Okay. So 2 1s are, 2 3s are. pi, and pi goes away here. So what is that I have? I have 3.5. There's a 10 power minus 2 here. There's a 10 power minus 2 here. This goes away here. 3.5 divided by 3, and there's 9 here. 9 into 7, which is 63 over here. 63. And what do you have here? You have 10 power minus 3. As much as possible, try to do it manually, and after that, if you want, you can use your calculators. Okay, so 3 into 7, 9, 7, so 63. So this is what we got. Now let me go back to my calculator to find out this value. This should now be, where is it? It should be 3.5 divided by 63 would be 0.055. Okay, so I'll write this as 0.055 divided by 10 power minus 3, which should now be, when it goes upwards, this becomes 550, right? 1, 2, 3, 550. What is it I need? I need 500 by 9. So what you do is calculate this 500 by 9 also. Okay, because I have 550 over here. I need to calculate this value here. Are we doing it correctly? Hey, is this 550? 1, 2, 3. Sorry, not 550. It's 55. 55 over here. So this value should also be nearly 55. Of course, you can look at this directly. You are getting it as 55 nearly. Okay, let me find out this value also. This is now, where is it? 500 divided by 9. 55.55. Right? So this is once again 55.55. So anyway, this value matches with this value, and hence this is also correct. So this, which are all correct, A, B, and C are correct, and A, B, and D are correct, and C is incorrect, right? So this is what we call it as IIT problems. Okay, so problems are not very difficult. Problems are quite easier only. So if you really like this video, do subscribe to my channel for more updates. So this will definitely help me out to reach you better, and whatever new things I'm doing, I can just put it across. And thank you for being with me. And if you have any other questions, you can always put across in the comments, and see you again in the next video. Thank you.